The MV-22 Osprey is a multi-engine, dual-piloted, self-deployable, medium-lift, vertical takeoff and landing tilt-rotor aircraft designed for combat, combat service support, and special operations missions worldwide. It is replacing the Corps' fleet of CH-46 Echo and CH-53 Delta medium-lift assault support helicopters. Welcome to the Osprey orientation video. This short video will give you a basic overview of the Osprey, its capabilities, planning considerations, and finally, how to safely ingress and egress the aircraft. A tilt-rotor aircraft combines the vertical lift capability of a helicopter with the speed of a turboprop airplane. The thrust comes from the prop rotors, part rotor like a helicopter and part propeller like an airplane. The Osprey is the first full-rate production tilt-rotor aircraft in the world. The MV-22 is on the leading edge of future tilt-rotor aircraft development. The Marine Corps has a current requirement of 360 MV-22s to replace CH-46s and CH-53 Deltas. The Air Force Special Operations Command has a requirement of 50 CV-22s to replace the MH-53 Juliet Pavelot. The Navy is also considering purchasing V-22s. Now for a brief overview of the Osprey.
The mission of a Marine Medium Tilt-Rotor Squadron is to provide assault transport of combat troops, supplies, and equipment across the spectrum of expeditionary operations. The V-22's specific mission capabilities include troop insertion and extraction, casualty evacuation, internal cargo, single and dual-point external cargo, para-ops, fast roping, spy rigging, and search and rescue. The unfolded MV-22 is 57 feet 4 inches long and 84 feet 7 inches wide from prop rotor tip to tip. Each prop rotor disc has a diameter of 38 feet and is located 20 feet 10 inches above the deck. The bottom of each nacelle is 4 feet 4 inches above level ground. In full stow, the Osprey is significantly smaller at 63 feet long and 18 feet 5 inches wide. The primary ingress-egress for troops is the ramp located at the rear of the aircraft. The aircraft will primarily use the forward crew door. Fleet aircraft will typically be configured with 24 cabin seats. In case of emergency, there are 6 emergency egress points.
The V-22 is powered by 2 Rolls-Royce turboshaft engines, one in each nacelle. Each engine produces 6,150 shaft horsepower. The drive system includes a series of interconnecting drive shafts that span the wings. If you have a single engine failure for whatever reason, the aircraft can still fly safely to a landing even when loaded with troops. The cockpit is almost entirely digital displays. The flight controls depend on fly-by-wire technology. The aircraft has an extremely accurate internal navigation system that blends with a GPS signal to ensure pinpoint navigation with a digital moving map. The aircraft also has a navigation-grade forward-looking infrared that can be manually controlled or locked to a latitude or longitude position. The V-22's range and speed increase the crew's ability to avoid threat areas entirely and still accomplish the mission. Even in a threat area, the susceptibility of a V-22 flying at 240 knots and 200 feet above ground is far less than a slower flying aircraft. The design of the aircraft places the mass of the major components over the wing tips as opposed to right over the passenger compartment, as in most helicopters. The wing box is designed to shear the wings and nacelles on impact and protect the troop-carrying cabin. The composite blades are designed to shatter after contact with the ground to further reduce the possibility of cabin intrusion. The troop seats are designed to absorb 13.5 Gs upon impact. The self-sealing fuel cells have been drop-tested and contain breakaway fittings to reduce the possibility of a post-impact fire. The bottom line is that the chances of avoiding and surviving an enemy engagement are much greater in the MV-22. Maximum airspeed is 280 knots. Cruise airspeed is between 220 and 240 knots. Maximum loiter time is 150 to 170 knots. The aircraft's range is dependent on many factors. The V-22 is capable of aerial refueling, so with the appropriate assets, the range is unlimited. The maximum combat radius of the MV-22 with a full fuel load is 485 nautical miles. This maximum range would require us to climb immediately to a high altitude and remain there until the descent into an objective area. For standard conservative sea level planning, units should use a combat radius of 375 nautical miles. Altitude makes fuel burn and ground speed more efficient. Therefore, our operating range will increase dramatically while at higher altitudes.
Second MAW SOP dictates the following. Passenger manifesting during tactical lifts is the responsibility of the embarked unit. Troop seatbelts will always be buckled from takeoff to landing. Helmets will be worn with chin straps tightly fastened. The helicopter team leader or senior person in charge will be provided a flight helmet or ICS cranial, which allows for communication with the aircrew.
In a maximum endurance configuration, an MV-22 can remain on station for a maximum of 4.5 hours. Normal time on station with a single fuel load and a mission profile is 3.5 hours. There are many different internal aircraft configurations for the MV-22. Here are a few examples. Troop transport, 18 combat-loaded Marines. Supported units should plan on 18 combat-loaded Marines per stick. If needed, we can use all 24 seats available for embarked troops. Casevac, 12 litters with 4 seats for corpsmen. Para-ops, 12 military free-fall jumpers, 16 static line jumpers, 8 per pass. Maximum gross weight.
Vertical takeoff is 52,600 pounds.
Short takeoff from a runway, 57,000 pounds. Self-deploy while airborne, 60,500 pounds. Currently, Fleet MV-22s have an M240 Delta mounted on the ramp of each aircraft. This system is operated by the crew chief and is intended for defensive use. The system can be mounted on either side of the ramp and will stow to the other side for ingress and egress of troops and cargo. In the event of a crash or controlled landing outside friendly territory, the ramp-mounted weapon system can be removed and converted into an M240 Golf for escape and evasion. The prop rotor wash of an MV-22 is considerable due to the low area and high load of the prop rotor discs. At idle, on the deck, the downwash is comparable to a CH-53 Echo. The downwash is dangerous because in a landing zone with loose debris, the downwash can cause loss of footing and flying debris.
When entering and exiting the aircraft, there are certain areas that you should be aware of. The combination of heat and wind blowing down from each nacelle is directed outward to keep the aircraft from heating up. Approach the aircraft from approximately 45 degrees from either side of the tail. Although it is safe to approach the aircraft from the nose, you should ingress and egress the aircraft from the aircraft's 8 o'clock to 4 o'clock. Upon stepping on the ramp, point your muzzle down and keep them down throughout the flight. The crew chief will be on the ramp to remind you and direct you inside. Once you enter the aircraft, the crew chief is responsible for both your safety and the safe operation of the aircraft. Move to the most forward available seat and follow the crew chief's directions. When looking for the next available seat, you need to alternate right and left sides of the aircraft. Once you reach your seat, remove your pack and stow it in front of you on the deck, not underneath your seat. For a hard landing or crash, the seat has to go downward to absorb the impact. The bottom of the pack should be at your feet. Once seated with your muzzle down, you will be required to fasten a 3-point harness. The fastener is similar to what you would see on a civilian airline seatbelt. Both the shoulder harness and lap belt can be adjusted to fit all body types. Tighten the belt and shoulder harness so that it is snug. In order to egress the aircraft, simply follow the ingress procedures in reverse order. In the event of an emergency that requires aircrew and troops to egress the airplane as soon as possible, there are 6 ways for you to exit the cabin. First and primary exits are the ramp and forward crew door. If for some reason these exits are blocked, there are 4 emergency exits that you can utilize. There are 3 window exits behind your seats, 2 on the left and 1 on the right. There is also an exit in the upper ramp hatch in the event of a water landing. Each of these 4 exits has an arm and fire mechanism that can be actuated anytime the safety pin is pulled. The crew chief is required to remove all safety pins before every flight, so you should never see them. The pull handle is black and yellow striped and located on the right side off of each exit. To operate the window and upper ramp exits, grab the handle, shield your face and eyes, and pull. To operate the emergency exits from outside the aircraft, find the rescue arrow and push the button the arrow points to. Grab the lanyard that pops out and walk away from the aircraft at a 45-degree angle to the distance of 10 feet and shield your face and eyes. Warning: the emergency egress should only be actuated in a life or death emergency. The window is lined with detonation cord and will blow off of the aircraft, causing severe damage to the airframe. If you have any questions about the MV-22, contact your forward air controller or air officer.